This video is going to look at axis intercepts of a quadratic. For a quadratic function in the form y equals ax squared plus bx plus c, the y-intercept is a constant term c, so the value added to the end of the equation. If you just look at the graph over there, I've just circled in purple, and then that will be the y-intercept. Quadratic function in factored form of y equals a, and then in brackets x minus the first value, and then the second bracket x minus the second value, has x-intercepts at those two values. So the values in the brackets are where the x-intercepts are, and you'll see on the graph here, our two values in the brackets are our x-intercepts. A quadratic function with the factored form y equals a, bracket x minus alpha all squared, touches the x-axis at that value in the brackets. So this value in the brackets here is the one x-intercept that we have, and it is the only x-intercept. This example here, we're just going to find the x-intercepts of all these four equations. First of all, y equals 2, bracket x minus 3, and the next bracket x plus 2. Now to find the x-intercepts, it is when y equals 0. And we go back to our knowledge of the null factor law and solving this equation. So for this to equal 0, we would need x minus 3 to equal 0, or x plus 2 to equal 0, and this will give our x-intercepts. So x would equal 3, and x would equal negative 2. They are the two intercepts. B, we've got y equals minus, and then in bracket x minus 4 all squared. Once again, if we're going to find the x-intercept, we want when y is 0. Only have the one bracket here, which means x minus 4 must equal 0 for this equation to be true. And that means x will equal 4. Part C, we don't have it in factorised form, which means we're going to have to go back to our skills of factorising. Now factorising x squared minus 6x plus 9, hopefully you will see that that is a perfect square. And we will have x minus 3 all squared. And then to solve and find the x-intercepts, we make that equal to 0. And then we have the one bracket, so just like part B, one bracket there, which means x minus 3 is going to equal 0 for this to be true, which means our x-intercept is at when x equals 3. Then the last one, D, y equals 2x squared plus 4x plus 3. We need to solve this for x. When you look at that, you may not be able to see how you can factorise because it may not be possible. So realistically, the quickest way would be to use the quadratic formula. So in the quadratic formula, we have the a value, which is a 2, the b value is 4, and the c value is 3. And our quadratic formula, I'll just write that for us to remember. So we'll have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And then we can just sub in the values. We'll have x equals negative 4 plus or minus the square root of 4 squared minus 4 times 2 times 3 all over 2 times 2. Simplify this down and we'll end up with negative 4 plus or minus the square root of negative 8 over 4. Now, because we have a negative underneath the square root, that means there are no real solutions, so there are no x-intercepts. Example 2. Example 2, graph each quadratic function using its axis intercepts. So our axis intercepts mean we need to find the y-intercept and the x-intercept. With this first equation, y equals x squared minus 2x minus 3, we have it in the first form, which means our c value, the minus 3, is the y-intercept. So our y-intercept is going to be at 0, negative 3. Then we need to find our x-intercepts. Now it is not in a form where we know them, so we need to factorise it or solve by the quadratic formula, whichever way works best for you, to find out those x-intercepts. So I'm just going to factorise because we can do that. And we make it equal 0. And when we factorise it, we'll end up with x minus 3, x plus 1. Then when we solve this, we'll have x minus 3 equals 0, and x plus 1 equals 0. So our x-intercepts are at 3 and -1. So our two x-intercept coordinates will be at 3, 0 and at -1, 0. Now we can plot this information on the graph to be able to draw it. Y-intercept is at -3. Our x-intercepts are at 3, 0 and at -1, 0. And then from there we can draw the quadratic function, and it's got to go through all those 3 points. And that's what that sketch would look like. B, y equals -2, bracket x plus 1, and then the next bracket x minus 2. So with this one really easily we can work out our x-intercepts is going to be when x plus 1 equals 0 and x minus 2 equals 0. So when x equals -1 and when x equals 2. Then to find the y-intercept, that is when x equals 0. So because we don't have it in the form like the part A, we need to work out the y-intercept, and we can do it when x equals 0. So it'll be -2 bracket 0 plus 1 bracket 0 minus 2. Solve that and you'll get an answer of 4. So our coordinates will be 0, 4 for the y-intercept, and then we'll have -1, 0 for the x-intercept and 2, 0. And now we can draw the graph. 0, 4 for the y-intercept and our x-intercepts, and draw our parabola from there. Then the last one, y equals 2, bracket x minus 3 all squared. First thing we can do here is the x-intercept, which there will only be 1 because we only have one bracket. And that will be when x minus 3 equals 0, so when x equals 3. The y-intercept, make x equals 0, so we'll have y equals 2, bracket 0 minus 3 all squared, which will give us an answer of 18. So our x-intercept is going to be at 3, 0, and our y-intercept will be at 0, 18. Just plot those 2 points, and we know it can only touch the x-axis once, and that's going to be at the 3, so we just have to draw it. Just touching the x-intercept at 3 and going through the y-intercept at 18. And that is the end of this video.